Hi everybody, so let's do a real quick recap of the different types of reactions. Because I think most people got it pretty easily, but a few people did say they were having trouble. Guaranteed you're overthinking it. So there are five main types of reactions that we're going to focus on. So first we have synthesis. Synthesis is you have multiple things coming together. So the example, I always use high school relationships for most of these. So synthesis, you have two people and they're separate and then they start dating. So that's synthesis, they're coming together. So I could have H2O plus O2 yields hydrogen peroxide or H2O2. Second is decomposition. You have two people who are dating and they break up. So we have hydrogen peroxide, kind of the opposite of this, will break down naturally to water and oxygen gas. That's why either you have the expendable bottle, or if you open up the brown bottle after you haven't used it in a while, you kind of get a fizz sound like when you open a bottle of soda, and eventually it just turns into water, which is why it stops bubbling if you put it on a cut. If you do that after a while, or if you use it to clean up blood, you can always tell where the blood is on a carpet, for example. Let's say you get a cut and you have it there, it's going to fizz up. If you leave the bottle too long, it decomposes just water and oxygen, so therefore you're not going to get anything from it. Okay, single replacement, you have one thing come in. So imagine that you have, I'll call it a homewrecker situation. Two people are dating, and someone in and swoops away one of them. Okay? So I could have FeCl3 plus Na, and then when I get to the second one, I'm going to have NaCl plus Fe, because Na swoops in and takes Cl away. Single replacement, one gets replaced. Double replacement, so I'm going to use a similar one. So I'm going to say I have FeCl3 plus NaBr. Yields, if you ever hear me say yield, it just means the arrow. Yields FeBr3 plus NaCl. Okay? So double replacements, you have Fe and Cl are together, Na and Br are together. They split up and go to opposite ones. And I'll show a couple more examples of these. Combustion, you will have something, usually just carbon and hydrogen, but occasionally carbon, hydrogen, and oxygen, plus O2 yields carbon dioxide and water. You can always tell it's combustion because you have these two here. Double replacement, the example, you might see two couples together in school, and then you look the next year, sometimes even a month later, and they've completely switched who they're dating with, and it's all the same people. Okay. So a couple things of terminology. As I said, the arrow, a lot of times I'll say yield. Everything to the left of the arrow is known as a reactant. Everything to the right of the arrow is called a product, okay? So let's look at the ones from yesterday real quick. Okay. So I have letter G here. So some of them I have here, some of them I don't. Just I want to give you an example of each type. So if I have Na3PO4 plus KOH, gives me NaOH and K3PO4. So I have Na and PO4 together. I have potassium and hydroxide together. When you go over here, sodium and phosphate split up, hydroxide and potassium split up. So this is, of course, a double replacement, both switch. If I'm looking at this one, my big hint, CO2 plus H2O. Okay, so it's not guaranteed it's combustion, but you look and say oxygen over here. Okay, this is a combustion reaction. So I have lead and iron sulfate yields lead sulfate and iron. So you can see it's single replacement because the iron here gets replaced by the lead. So that's single replacement. Calcium carbonate yields calcium oxide and CO2. This is decomposition. I start with one thing and it breaks down. Okay, and my last one, I have P4 plus O2 yields P2O3. So that's synthesis because I'm creating something. If you ever look at English and they say synthesize an essay, it means to create photosynthesis, to make food with light. Okay, so the other ones we have here, so H was, let me just grab my little answer key here. So H was double replacement. M was double replacement. N was single replacement. O was combustion. P was synthesis. Q was single replacement. R was double replacement, and S was decomposition. Okay. When we have a quiz and stuff like this, it'll be all on the computer, but on a worksheet you can always abbreviate it as DR for double replacement, SR for single replacement, C for combustion, S for synthesis, D for composition. You don't have to, but that's up to you. Okay, so now what we're going to learn how to do today is how to balance reactions. So I didn't account for the fact of how many of each thing were here. Okay, all I did was I look and say I took out the numbers just to make it easy for us. So other than the subscripts, which are part of the formula, like we already learned how to do, but we have to balance. So law of conservation of mass says that matter cannot be created or destroyed, only transformed. So what that means, when I go to the end of one of these, I have to have the same number of each element on each side of the equation, in my reactants and my products. So I can do that by putting in a number, for example, here. So that's saying I have 3 moles of sodium hydroxide, or I have 1 mole of potassium phosphate. Okay? So I'll show you how to do that. It's actually not that bad. So let me just flip us around to the other board. Give me 1 second to erase. Okay. So we're going to start with number 1 from the worksheet. So I have blank NaBr. Let me drop the board just a little more. Sorry, it's a little too wet for the marker to like it. Okay. So I have blank NaBr plus blank H3PO4 yields blank Na3PO4 plus blank HBr. I just want to get those in the same order. Okay, so first thing we do is we do just a simple T-chart because we want to know how much of each side we have. I really, really, really do not recommend doing this in your head because it's far too easy to get confused, especially some of the later ones on this worksheet. But this is what I recommend. It's up to you. When we have the quiz on this, you're going to have to be able to pick the right number or type in the right number. And it's either going to be right or wrong. There's no way to do partial credit on that. Okay, so I'm going to do R and P, reactants and products, and make a little T-chart. I'm going to write each element that I have up here. So I have sodium, I have bromine, I have hydrogen, I have phosphorus, and I have oxygen. However you set up your table, pen, pencil, whatever is fine. When we're actually tallying these, I really recommend pencil because we're going to end up changing them, okay? Same thing, I recommend doing all this when you see me putting in numbers in pencil. Obviously I have dry erase, but I would use pencil because you're going to need to change them. It's a trial and error process. Okay, so I'm going to start with what I have initially. So on the reactant side, I have 1 sodium, I have 1 bromine, I have 3 hydrogens, 1 phosphorus, and 4 oxygens, okay? On the product side, I have 3 sodiums, I have 1 phosphorus, I have 4 oxygens, I have 1 hydrogen, and 1 bromine, okay? I will not grade you on this chart. It is just a tool to help you. So I find something that is not even and try to make it balanced. So for me, I'm going to look and say, okay, sodium is not balanced. So I want to make this into a 3. So if I want to get 1 to 3, I multiply it by 3. So I'm going to put a 3 right here. That means I have 3 sodiums, but I also have to update because now I have 3 bromines. Okay? Now bromine's not even. Let's fix that. I need to make the right-hand side 3. So I'm going to put a 3 here. So now I'm going to have 3 bromines and 3 hydrogens. Now if I look, 3 and 3, 3 and 3, 3 and 3, 1 and 1, 4 and 4. You can go back and double check it if you want to, okay? So my final answer would be 3, 1, 1, 3. Because anything that you don't write something on the line, you write in a 1 for. Because you're saying you have 1 mole of it, okay? Give me 1 second to erase and we will work on our next one. For this part, it really helps to have some scrap paper around. Doesn't have to be anything fancy. You don't need to save your chart. I don't need to see that. But it really helps to have space to do a chart. If you take a chemistry class in the future, a little whiteboard like we have in class also works great for this too. Okay, let's try, let's do an easy one, number 3. So I have blank magnesium plus blank Fe2O3, sorry, this marker's starting to go, yields blank iron plus blank magnesium oxide. Now, I'm always going to give you the formulas. If we were in school, I'd start putting it in words. You'd have to write the formula out. I'm just going to give you the formula all written out with the blanks like you see on that worksheet. So don't stress over having to create your formulas if you don't remember. Okay? Okay, let's make our little T-chart. So I have reactants and products. So I have magnesium, iron, and oxygen. So I have 1 magnesium, 2 irons, 3 oxygens. 1 iron, 1 magnesium, 1 oxygen. It does not matter which one you start with. The only thing I recommend, so you're going to see later in this worksheet, you might have oxygen, might be in more than one thing. Save it for last. If you balance everything else, it will resolve itself. Okay? So if you have something that is in more than one thing on a side, you can save it for last. Okay? So everything will become balanced. So if I look, okay, magnesium is good, iron is not. I need a 2 on this side. So I can write a 2 in here. I have 2. Easy fix. Okay. I need a 3 here, so I'm going to put in 3. Okay. But I also have to update my magnesium because I now have 3 because it distributes in. And then I write a 3 here. Now I have 3 and 3, 2 and 2, 3 and 3. And you can always check it back up here if you want to. Okay, I put a 1 in because I don't have that there. Okay, let's try number 6. I know I'm giving you answers to worksheets we're actually working on in class. But that's okay because we'll work on this for a few days. Okay, so for number 6, we have 2 NH3. That's still a little wet right there. Plus blank I2 yields blank N2 H6 plus blank H2. Okay, let's do a reactant to product chart. So I have N, H, and I. And yes, I'm doing the classic teacher thing, and I'm doing the easier ones and saving the harder ones for you later. You can, of course, come to the live lesson and we'll work through those if you'd like to. Okay. So I have, whoops, get rid of that 2. Oops, little hint for you. So I have 1 N to start. I have 3 H's, 2 I's. I have 2 N's, 6 H's. Whoops, sorry, this must be I6. Sorry guys, too many of these, you will do the same thing. Okay? Sorry, we have 2 H's and 6 I's. Okay. Sorry, let me drop that off because that is not rating. There. Close enough. Okay. So what's not even N? So I need to put a 2 over here. Okay. So now I'm going to have 2 N's for H. 2 times 3 equals 6. Okay. I am not going to touch for a second. I'm going to look over here and say, okay, let me fix my H's. So if I put a 3 in here, because I need to get to 6, and 3 times 2 equals 6. That's a common one where you will see 2 on one side, 3 on the other. You're going to look for 6 as your least common multiple, okay? If you ever go too much, you can always come back. Okay. Now so same thing. I have 6 over here. This comes in 2s. I'm going to do 3 because 3 times 2 equals 6. Okay. So my answer is 2, 3, 1, 3. One quick pointer. So let's say you had done all this and you came up with 4, 6, 2, 6. If you can reduce it, you reduce it. Okay? So obviously I can divide all of these by 2. Okay? So if you always check your answer at the end, because sometimes people just go overboard. You know, how just the math works, they get up and they get to too many numbers. If you can look at all of them and reduce them by a similar factor, by dividing by 2 or dividing by 3, do that. So we'll have the live lesson that you're welcome to join for, and I can work through other ones on the worksheet if you need help. And I know that you need to find the reaction types, and I didn't tell you for this. I want you to try them as you do them and see how you do with reaction type, okay? Have a great day, and if I don't see you at the lesson, have a great weekend, and I'll see you on Monday.